In our preceding 3 videos, we've just been really kind of setting up and articulating the logic. And I know I'm taking a much more deliberate period of time to do this, but this is kind of the process I want you to be taking. All right. And when we left off, we said we're going to ultimately use SciPy, and we're going to use to come up with a correlation, and we're going to use a Pearson statistic. Okay. So I'm not going to go over Pearson. Pearson is theoretically normally distributed data. The other statistics that you can run depend on if it's categorical data, etc. So in this particular case, we're using a Pearson statistic because it seems to be a continuous variable between 2 endpoints, if you will. All right, so all right, so simply, it's not a hard thing. It's SciPy dot stats dot Pearson R. That's the correlation. And what I want to correlate is DF summary S and DF summary F. That's it, right? So we're going to run this and see what happens. SciPy has no attributes, stats. So I think I have to bring in the stats function, and we did that in the last script. So I'm going to pull that up here in a second. So I pulled up that last thing, and I forgot from SciPy. So we import SciPy, but then from SciPy we also have to import stats. All right, that's why it wasn't coming up here. So let's put that in. And we're going to run that. Now, let's try running this. Beautiful. So this tells me that I have a correlation coefficient, right? The way to read this is I have a correlation coefficient is about 0.3, is about 0.39, right? With a p-value of 0.0038. Okay, so there's a 0.38% chance that these are not related. Okay, that I'm pretty comfortable with, right? I'm going to interpret this as a relatively strong relationship between sales dollars and freight costs that I'm charged. Okay? So that's SciPy. Well, pandas and NumPy can also execute correlation. So let's, remember I told you there's lots of different ways of doing this. So let's look at pandas and NumPy can also correlations. All right, so here's the here, let's do the panda example. Okay, so in this particular case, we're going to take DF summary S, and we are going to correlate against df summary f. That's it, right? Let's run that. And I get that same correlation coefficient, that 0.39. So I don't get the p-value. That would have been nice, but I don't get the p-value. It's okay. All right, well, what does the numpy's version look like? All right. Right? In NP CORRCOEF gives the correlation matrix versus just the correlation coefficient. That you get in pandas and SciPy. Okay, so NP dot CORRCOEF, and we want to get the correlation between DF summary S and DF summary F. What is going on? Oh, I know why. I know why that NP didn't work before, because I read it in as MP, not NP. Hello. So now my NPs, so this, if I will go back here and put in NP sum, I won't get that error that I was getting before, right? So I want to see, yeah, run both of those. Now I have my series, I can run my stats, same thing. All right, so now let's do the NP correlation coefficient and see what that looks like. All right, now I've got my matrix, right? So if I had multiple, if maybe I've had 3, 4, 5, 6 variables, I'd get a correlation matrix, right? Where the on diagonals are always going to be equal to 1, and the off diagonals are the ones that you want to pay attention to. Those are the ones that have the correlation coefficient in it. All right, so it depends on which one you want to use. All right, as far as looking at the different methods, right? So 3 different packages all give us this, can all give us the same outcome. So you choose which one you ultimately want to utilize.